Hello, good morning. I'm continuing my lecture for part 2. This at slide number 11, titling Surfside Hotel Reservation System. So if you take a look at this matrix, so basically this is the reservation for the hotel expecting for no-show against the probability. So no-show from 0 up to 9, and the probability is given in this column at 0.07 means 7%, 0.19 means 19% to happen, 0.10 means 10% to happen, and 0.01 means 1% to happen. So the scenario setting is that this hotel, to stay, it will cost for $40 per night, right? So in order to calculate this and for opportunity loss, for a room costing $40 per night, so we have to multiply all the no-show from 0 to 9, multiplying with the probability index. Then we have the total probability index of 3.04. And this total expected opportunity loss of 3.04 multiplied by hotel cost fee per night by 40, then it has total of $121.60 per every night no show. So in general, the management of the Surfside Hotel estimates for roughly around $1 per night loss for any one guest walk away, in which that guest need to go to the other hotel to stay. So one night costs $100 per night by experienced by the customer that is being refused to stay at the hotel. Okay, next, if we take a look on that matrix and we expand into the overall overbooking possible loss table, so you could see this matrix from no-show from 0 to 9, and you could see also the overbooking from 0 to 9. Well, as I told you earlier, the estimated loss of one customer walkway is $100, right? So we have to fill up this matrix by starting at one overbook with one no-show. So if one overbook, one no-show, it will cost 100, right? So if it is two overbook with no-show, it means you're gonna lose 200 and multiply subsequently by another 100, add another 100, become 400, another 100, become 500, and so on up to 9 overbook or 9 walk away customer will contribute for loss $900. Okay, as we told you earlier that for one night of stay, it will cost at a hotel for $40. So if one no-show, it means $4 lost. If two no-show, it will be $40 multiplied by 2, 80, and 3 respectively, and 60, right? Sorry, 120, 160, 240, and so on. So it is $40 multiplied by the number of no-show. So the total cost of expected loss for this situation is 121.60 cent, which is sum up or round up to $100 per night. Okay, these are the estimated situation of the overall matrix. So if you take a look here at the diagonal, there is a line of zeros. This means that if you overbook 1, right, and no show 1, that means you incur no loss, right? Then if you overbook 2, and actually no-show 2, then you incur no loss, and respectively the same. If you overbook 9 but actually 9 no-show, then the hotel incurs no loss. So this is what is all about how to interpret the metrics of this overbooking loss table for the hotel. Now, let's calculate the opportunity loss for not overbooking. How much you will lose if you do not book? So, the formula is summation of the expected number of no-show. How many number no-show? It got to be multiplied by the number of night. Okay, number of cost of the room per night. That will equal to the OL, which is opportunity loss. So let's calculate the probability of opportunity loss for the whole situation, in which for 0 no-show, you multiply it by the probability 0.07, and for 1 no-show, you multiply it by the probability of 19%. So the 2 no-show multiply by the probability of 10 to 22%, 3 no-show multiplied by the probability of 16%, and so on up to 9 no-show multiplied by 1%. So the probability index accumulated is 3.04. So that is the probability index, the probability that it will happen. So this probability index you multiply by the cost of staying at the hotel, $40 per night. So you will have the total sum of $121.60 per night. This is the opportunity loss for not overbooking, right? If the customer doesn't show up. So as such, if you want to decide what is the number of rooms that is most favorable for the hotel to engage the overbooking, it is 2 rooms, right? By referring to this table. Okay, at 2 rooms, at overbooking of 2 rooms, so you will see that the PD is actually smaller than the PDX. Okay, here PD is 0.7, and the PDX or PX is 0, and here PD is at 0.19. The cumulative PDX is 0.7, and at the probability of 2 no-show, the probability is 0.22, right? And this is smaller than 0.29. On the top, it is this one is bigger than this one. So if you take a look at no-show 3, this value 0.19 is smaller than 0.48. So as such, at no-show number 2, that is the optimum number of possible overbooking to suit your business nicely, which is at 2 overbooking, right? So this is shown by at the level of PD is less than PX, PD, and this is PX. The cumulative probability means that the strategy of overbooking by 2 room is the most favorable, right? Because this is less, this is small, small, and big, right? And at 22 is the turning point. This go up, and then it goes down to 0.16, 0.12, and so on. So this is the utmost position that is most profitable, most suitable for the hotel to engage in overbooking, which is 2 overbooking at all time. Okay, so 2 overbooking is the most favorable policy that they engage, that the hotel can engage for their management practices of reservation. Now, let's calculate the opportunity loss by practicing overbooking by 2 reservation. So, in this situation, we have to calculate this table, okay, of this the no-show and the probability. We calculate all this by multiplying to each other. So now we're gonna have like 0.7, which is 7%, okay, multiply by 200, okay, plus 0.19 multiply by 100, okay, and plus 22 multiply by 0, and then plus 0.16 multiply by 40, plus 112 multiply by 80, and plus 0.10, which is 10% multiply by 180, right? And then 0.7 multiply by 160, right? And 0.4 multiply by 200, and 0.02 multiplied by 240 plus 1% multiplied by 280. This means a total of 80 cent of the opportunity loss by practicing overbooking for two reservation. Okay, so the overbooking by two rooms will minimize the expected loss in the long run if it is adapted as its standard policy for the hotel. So, in other words, if this policy is adopted, one can understand that an average gain of 33.80 per night from overbooking can be saved, okay, can be incurred. This is the difference in the expected loss between not overbooking, which is 121.60, right, which is this. For not overbooking, you will lose 121.60 cent, and the against the expected loss from overbooking, right? So the expected loss is only 87.80 cent, which is this. So this is one the major reason why hotels engage overbooking, right? Because it is a strategy to cater at optimum how many people will not come after they engage the booking earlier. So overbooking by two reservation in this case is the best to minimize loss. Okay. So this is that's how to calculate the opportunity loss. Now let's take a look on the calculation sample. The scenario is Ryanair Airlines is considering overbooking of its flights to avoid flying with empty seats. For example, the company is thinking of taking 11 reservation for an airplane that seats only 10 passengers. So it means that how many overbooking? It means only one overbooking. This below table shows the column of no-show against the percentage of the probability that it will happen, in which for Ryanair, for no-show, it's about 30% of probability it will happen. For 3 no-show, it is about 15% of probability it will happen. And the same for 4. So the operating costs of Ryanair is consisting of pilot, which cost them ringgit Malaysia 200, first officer 150, fuel 70 ringgit, and landing fee 30 ringgit. And this is a total of 450 costs for the flight. And a one-way ticket for any air costs RM 180, which is ticket cost for one seat is 180 ringgit. So the question is, if the cost of not honoring a reservation is a free lift ticket worth 50, so if there is a passenger cannot get the seat, so Ryanair could put this passenger to the other flight, which is will cost them 50 ringgit a seat for the next flight, or to the other airline company. So then what is the recommended number of passenger to engage overbooking under this situation? So let's see how we resolve the calculation. Okay, so here is the table of the proposed solution, right? So 4 no show and 4, of course, 4 passengers overbooking, right? So this is how the table is set in order for you to make decision how many overbooking passengers you need to engage, right? In actual fact, there are only 10 seats in your airplane, but you need to engage how many overbooking to safely your company to protect your company from no show. Okay, that is the solution is being proposed. So let's work out this table, how to decide how many overbooking passengers to safeguard your company from loss due to no show. Okay, so first, you need to create a table. Okay, so you need to create a table like this: 2, 3, 4, 5, 6, and 7. And also, again, 7 row, right? Because of the requirement of the setting. 3 row, 4 row, 5 row, 6 row, and 7 row. Okay. In reference to this scenario problem that we are trying to simulate the calculation. Okay. Now, here is no show. Okay, here is the probability, and this is the number of overbooking. This is overbooking. Okay, this is the number of no show. Okay, so overbooking 0, 1, 2, 3, and 4. And of course, if it is 4 overbooking, the no show also got to be 4. No show 0, no show 1, 2, 3, and 4. Right? So again, so based on the given probability or percentage it will happen, so which is this. So you transfer this value to the table, which is 30% means 0.3, right? So 25% 0.25, okay, 20% 0.2, 15%, and 10%. Okay, so how to uh, how to basically estimate the profit if there is no overbooking and no zero no show. So basically, profit, okay, is derived from the sales of 10 seat per passenger, and then multiply by the cost of operating the flight routes, okay, which is 180 is the cost of a ticket. Okay, passenger buy 180 multiplied by 10 seats. Okay, then you minus the cost of running the airline flight for per flight is 450, and totaling for 1350. So for the situation for overbook, zero overbook and no show, in the actual situation in which 10 booking, all people show up. So the value, okay, of the profit okay, is 1350. So if there is one overbook, so you have to they have to take a flight away ticket, which is one flight away ticket is 50 ringgit, which is 1350 minus 50 for one overbook. That means 1300. If there are two uh, flight of ticket passenger experiencing, so the company must pay 50 ringgit multiplied by 2, which is another 100. So this will become 1250. Okay, so if it is 3, it means 150, because RM 50 multiplied by 3. So this will become 1200, which is 1350 minus 150. It become 1200. And respectively for 4, it will become 1150. Okay, so if there is one no-show, so the company has to lose a ticket, which is costing 180 per seat, because one no-show. So one booking, but actually the passenger doesn't come to take the flight. So basically 1350, you have to minus 180. So this will become 1170. So again, if 2 no-show, which is 180 multiplied by 2, then minus by 1170, right? This will become 990. And 3, the same, 180 multiplied by 3 minus by 1350. So you have 810. Then 4, same, 180 minus multiplied by 4, then 1350 deduction is 630. Okay, so in the situation for diagonal, for this diagonal line, okay, right? So if 0 overbook, 0 no show, which is profit 1350. So in case if you overbook 1 but no show 1, so this is again 1350. 2 overbook, 2 no show, again this is 1350. 3 overbook and 3 no show, again this is 1350. And 4 overbook, 4 no show, again this is 1350. So iteratively, so the same sequence of number follows. So after 1350, 1300, so this become 1300, then 1250, and then 1200. So same after 1350 is 1300, is 1300, and then this goes to here 1250. Again, this one follow go to here 1300. Alternately in sequence number. So this is the same. So for 1 overbook, 2 no show. So this will become 1170, 990, 810, right? And this is also same, 1350, this is 1170, and this is 990. This one 3 overbook, okay, 4 no show, it will become 1170 here. So if you sum it up, all this column, then this will become 1080, and this will become 1191. Sum it up. Summing up this column for 2 overbooking, you will have 1244.5. You summing up this 3 overbooking, 1252. Sum up all these 4 overbooking, we have 125. So now the question is, what is the best overbooking level possible for this Ryanair flight? So again, you take a look on the profit possibility that can incur is, this is 1280, okay, and then it increased to 1190, and then later for 2 overbooking, right? So they have 1244.5, and then later increase to 1255 for 3 overbooking, and suddenly at 4 overbooking it decreased to 1225. So up, going up, increase for 3 overbooking, and at 4 it reduced to 1225. So this is the most optimum peak value for profit at the level of 3 overbooking. So for Ryanair, that its plane has 10 seats, the best combination of profitability that they can engage is having three overbooking. So it means it can accept 13 reservation, which is 10 plus 10 is actual, 3 is actually overbooking, right? So this is the answer, okay, for the question that is being asked in this one, right? If the cost of not honoring a reservation is a free lift ticket worth 50 ringgit and a seat is on the next flight, then what is the recommended number of passengers so that Ryanair can engage overbooking? So the answer is basically 3 overbooking, right? Okay, that's the way we calculate for the overbooking for this scenario situation of Ryanair Airlines. So I hope you understand how to calculate this overbooking situation, right? So thank you for your attention. So later we'll continue with part number 3.